Hello everyone. So I'm sure you're happy we are here. I guess this is probably bittersweet. Cause thing. But these are our key integration formulas, and I uploaded these to Canvas on the course essentials module. So at the very top of the Canvas page you'll find the antiderivative formulas, and you'll see this worksheet which has all of the formulas that you need to be able to finally use the antiderivative formulas to evaluate integrals. In the last video, we said that the fundamental theorem of calculus allows us to use the antiderivative and plug in the bounds to evaluate definite integrals. So I'm going to do an example because in the last video I only did examples for part 1. Now we're going to use part 2. So use part 2, which remember part 2 just tells us that we can take the antiderivative and plug in the bounds when we're evaluating definite integrals. So the integral from -2 to 2 of t squared minus 4. Right, so remember, the first thing we want to do with this, remember the property tells us that we can take the integral term by term. So you don't always have to write this out, but I'm going to just to emphasize the point that I can integrate t squared and then I can integrate 4. Right, and just subtract them. So if I look here, we see we have the most commonly used rule probably is the power rule, which says if you have x raised to some number n, then you just add 1 to the power and you divide by that new power. Right, so if we have t squared, we add 1 to the power and we divide by the new power. Right, and we're going to have to evaluate that at -2 and 2. And then for 4, remember, if we just have a constant, right, k, then it just becomes k times x. Right, so this just becomes 4 times x, right, because our number k is 4 in this case. So now we have to just plug in the bounds. So we plug in 2 in for t, so that becomes 2 cubed over 3 minus, and make sure you were plugging in -2, so it's the entire -2 cubed all over 3, and then make sure you put brackets around this next part because this negative sign applies to this whole thing, so you need to be very careful with your signs. So then this becomes 4 times 2 minus 4 times -2, and then 2 cubed is 8 over 3, and then -2 cubed, that's -8, but then negative times this negative here, that's going to become positive 8 over 3, and then we have minus, and then 4 times 2 is 8, and then this is going to be plus 8, so this is going to become 16 over 3 minus 16. So then I can just change the 16, right, multiply that by 3, that becomes 48 over 3. So this is really -32 over 3. So basically with part 2 now we're able to just take the antiderivative of whatever functions here, plug in the bounds, and then that's how we find the definite integrals from here on out. So much easier, well, I don't know, I guess that's subjective, but much more direct, I guess, algebraic manipulation instead of looking at graphs like we were doing before. And again, you don't have to always split up the terms like this unless that helps you, but I was just showing you guys that property that we can go term by term, right? So you don't have to show this step, you can just do it directly, the antiderivative of that, antiderivative of that. All right, thank you guys.